In today's class, you will be able to understand angles outside the circle and circumscribed angle theorems. And you will be using these theorems to solve the problems. Well, the first theorem is angles outside the circle theorem. Angles outside the circles. So let me write that it is angles outside the circle theorem. In this theorem, you know what is a tangent? Tangent means it is a line segment that touches the circle at one point. Okay, so let me take say that this is the tangent. Okay, and this is another tangent. This is another tangent. You may get a doubt. Is it only tangent? Then how about the other cases? Means I'm taking altogether three cases. Suppose let's say that a tangent is drawn. You see that this is touching at one point and another line segment is drawn. Is it a card? Is this a card? Means the answer is no. What is a card means? It is a line segment. I hope you remember the definition of a card. A line segment whose both the endpoints are on the circle. But here, in this case, this is not the endpoints are not on the circle, right? So we call this as a secant. Secant. Again, I am repeating. If a circle is touching at one point, we call this as tangent. And if a circle is being intersected more than, it's intersected 2 points, we call this as secant. We call this as secant. So I'm going to discuss three cases. One is a tangent, and this is another tangent. These two are forming an angle outside the circle. Outside the circle. And in case two, again, a circle is taken as secant. Please remember secant means a line segment intersecting a circle at 2 points. And next, case 3 is, let me draw another circle. And here, this time I'm going to take two secants. Let's say that this is one secant. Please notice that it is intersecting the circle at 2 points, and this is another secant. This is also intersecting the circle at 2 points. Okay, therefore I'm taking two secants. So already I explained what a secant is. Secant means it's a line segment that intersects the circle at 2 points. Therefore this is a secant, and this one is also a secant. Again, these two secants are making an angle outside the circle. Now, how to figure out the value of the angle which is formed outside the circle? For all these three, the rule is the same. If you want, I'll give you three different rules, but for all these three, the rule is the same. That is angle, let me use a different color. Angle outside the circle, equals to half of the measure of long arc subtract measure of short arc. So you see that in case 1, do you see that two arcs, like here is point A and here is point B, and let's say that the angle is point P. Okay, this is the long arc, right? And let me take maybe a different color. Yes, this is the short arc, right? For example, let's say that this is given some 250 degrees, the length, the arc value, and this one you say that 110 degrees. Let me change the numbers. Let's say that this is 260 and the short arc is 100. Therefore, if you are asked to find what is the value of the angle formed here outside this circle is, it is angle P equals to half of the measure of the long arc. So measure of long arc, you see that it is 260 degrees, subtract and the small arc which is 100 degrees. Just you subtract, we follow PEMDAS. 260 take away 100, then you'll get that to 160 degrees. So half of 160, so the measure of angle P equals to 80 degrees. I know that if you take any textbook there, you may see that three different formulae, but all these three gives you the same idea. All these three are the same. So let me take second case. In second case, let's say case 2. Again, I follow my general formula. General formula means that is of the length of long arc of the measure of the long arc, and take away the small arc means, guys, here small arc means that it is in between these 2 points only. You have to take, you cannot take the entire thing. In the same way, if you take the third case, the long arc means you compare that, there are two arcs. So one is this one, and the short arc is this one. If you want, if I label them as A, B, maybe this is C and this one is D, therefore the value of angle P equals to, let me take all the three cases, case 3. So the value of angle P equals to half the measure of the long arc. Again, long arc means there are two arcs. When we are computing, the longest of these two is arc BC, subtract arc AD is the smallest one. So BC subtract AD. Now coming to case 2. Again, the measure of angle P equals to half the measure of here you see that this is the longest arc as I compare with the other one. Let's take A, B and C. So I see that the longest one is the black arc, which is BC, subtract the short one is arc AC. Okay, and if you take two tangents, here you see that this is the long arc which is outside, the outer one, and the short arc is the inner one. So measure of angle P equals to half the measure of arc AB which is the longest one, or I would say that major arc, subtract measure of the minor arc, which is less than half a circle AB. Okay, I see that I copied AB and AB, so to avoid the confusion, let me mention that it is major arc AB and this one is minor arc AB. So the general rule is if you are computing the angle, just simply remember this part, which is let me take a little dark color. So take this general rule that angle outside the circle equals to half the measure of long arc take away measure of short arc. Okay, questions on this? So let me take an example of the theorem which you learned. Let me, if you want, I'll draw the rule, etc. once again. Suppose if you are given a circle, let it be two tangents, two secants, or one tangent, one secant. The rule is always the same. Okay. Keeping the question in view, I am writing the condition once again. The condition says that this is the tangent. What is tangent means? A line segment that intersects a circle or that touches a circle at one point, and next one is this is secant. What is secant means? A line segment that intersect the circle at 2 points. Just I am taking the same diagram which is given in the question. So point C is here, and here point D, and next point B is here, and next point A is here. Okay, so one rule just you remember in mind, that is simple thing is that I see that there are two arcs are formed between the legs of the angle. Do you see the two arcs? There are two arcs in between the two legs of the angle. One is a long arc and another one is a short arc. Do you see that? One long arc and one short arc that is formed between the two legs of the angle. This shading etc. you need not do, but if I do that, you can better understand. That's the reason I'm shading this one. You see that I'm talking about these two arcs between the two legs of the angle. So one is the long arc, which is outside, and the other one is the short arc. This is the short arc. So if you see this kind of question, the external or the angle which is formed outside the circle, you see that this is the angle which is formed outside the circle. So the value of this angle equals to that is angle C equals to half the measure of long arc value. What are the value of long arc? Just I'm keeping this symbol so that you may not forget. Take away the value of the short arc. Okay, that's it. So let me take this rule. And oops. Okay, so now here let's plug in the values. The value of angle C equals to half of what is the measure of long arc? I see that here the measure of long arc. Even you can read the numbers. The highest value is 178. Subtract, and length of short arc means here, the measure of short arc, you see that 76 degrees. that is the smallest of these two values, right? Now 178 take away 76. We follow PEMDAS, so which are in parentheses, those values are to be simplified. Then you'll get 102 degrees. Now what is half of 102 means? That gives you 51 degrees. So that's the measure of the angle which is formed outside the circle by a tangent and a secant. Any questions on this? Well, let me take some questions. First one is, okay, a circle is given and two secants are given. Here, I don't care whether the given line segments are secants or the tangents. So what I'm doing is, let me identify that, okay, so this is the area between the two legs, right? So let me identify which is the short arc and which is the long arc. Okay, so I'm taking that. Oops. Okay, I see that this is the short arc and this is the long arc. This is long arc. So whatever the question it may be, first of all, let me write the condition first. The condition is the external angle, okay, or angle outside the circle. So let me write that angle outside the circle, equals to of the measure of long arc subtract measure of short arc. So I see that in the given diagram, two arcs, one is long and one is short. So here, half of measure of the long arc, I see that measure of long arc is given. It is not given, A is given. So let it be A. Subtract measure of short arc, you see that it is 44 degrees. It is 44 degrees. So this value to be copied here. So let me write subtract 44 and the angle outside the circle is given as 30 degrees. So let me write that value here. So let me write 30 degrees here. So our goal is to figure out what is the value of A. Therefore, we have to isolate that. For that, we have to start eliminating one after the other values, right? So let me eliminate this 1 over 2. You know that we go by inverse operation, so times 2 on both these sides. So 2 times f, that one gets cancelled and we'll end up with 1. Then 2 times 30, 60 equals to A minus 44. You know, once again, we take the inverse operation, which is inverse operation of negative 44, that is positive 44. So add 44 on both these sides, then this one gets cancelled. The value of A equals to 60 plus 44, that gives me 104. So the value of A is 104 degrees. Okay. Now questions on this. If you have any questions, you may email me. Let me take another question which is similar to this one. Always my strategy is I look at the question and though it is not required, my method of doing is so this is the area between the two legs of the angle. Therefore, let me identify the key parts. So this is the long arc, this is long arc, and this is the short arc. In fact, the length of short arc is missing. Okay, please do not go out of this one, because this is not in between the legs of the angle. It is not in between the legs of the angle, so you have to take only that much. Okay, I don't know what is the value of this angle, so let me assume that this is x, and angle outside the circle, I see that this is given as 45. This is given as 45. Okay, so let's go back and take the same rule. Please don't forget, I want you to write this formula every time. This formula every time. Okay, so let me write the formula here. Okay, so angle outside the circle, I see that that is 45 degrees, therefore that goes here. Just you have to plug in the values. Angle outside the circle is 45 degrees, therefore let me write that 45 degrees equals to half of measure of long arc. Here is the measure of long arc, and that goes here, which is 130 degrees, and measure of short arc, I see that this is the short arc value, and that goes here, which is x. Okay, now our goal is again to isolate the variable. So let me take times 2 on both the sides. So 2 times 45, that gives me 90. 2 times f, that is 1. 1 time anything, that gives me 100. The same. So it is 130, subtract x. Now again our goal is to isolate the variable. Therefore, there is no sign associated with 130. Let me take positive sign, and let's go for the inverse operation, which is subtract 130 on both the sides. So when I do that, 90 take away 130, it is not 40, but it is negative 40, equals to negative x. I hope you know that on both these sides, if you end up with a negative sign, then you may strike those two negative signs, then the value of x equals to 40. Therefore, whatever we got, that's the value of the x. That's the value of the x, means that is the value of the this one. Okay. Now, questions on this? Any questions on this? This is slightly different. Why is this different? Means, first of all, my strategy is, let me take the area between these two legs of the angle. Okay, this one. So first of all, let me identify which is the long arc and which is the short arc. So between these 2 points, I see that this is the long arc. This is the long arc, right? And this is the short arc between these two sides, right? So let me take the condition, which is angle outside the circle equals to half of the measure of long arc take away measure of the short arc. Okay, so let me plug in the values. It seems very simple, and I see that the angle outside the circle is not given, therefore let it be x equals to then half of the measure of long arc. You see that this is 250 degrees. This is equals to 250 degrees. Okay, my bad. Okay, so oops, this is so this is 250 degrees. Okay, no problem. Then subtract. Guys, what is the measure of the short arc? Oh, so here already x is given. So can I have two unknown values? The answer is no. So how to figure out the measure of the short arc? It's not given in the question. But if you take a circle, the total angle is 360 degrees. Out of 360 degrees, I know that some part is given as 250. What is the remaining? What is the remaining value? So that is 360 take away 250, because 250 is given a partial value. So what is the remaining part means when you subtract, then you get that 110 degrees. Therefore, measure of this one equals to 110. So let me use my PEMDAS technique. So 250 take away 110. It is 140 degrees. Now half of 140 degrees, that gives me 70 degrees. That's the measure of the x, which is the outside angle of the circle, that is 70 degrees. Okay, questions on this? Okay, another theorem is a circumscribed angle theorem. The next one is a circumscribed angle theorem. So what is this circumscribed angle theorem means? Suppose say that a circle is given, and you know that this is called as a tangent. This is called as tangent. And from the same point, I'm drawing another tangent. Let's say that this is the center of the circle. Let me mark the center of circle. Say that this is the center of circle. Okay. From the center of the circle, I'm drawing the radius. Please notice that tangent means, let me label these parts. Say point P, and this is point A, this is point B. Okay, and this is O. So here, remember that OB is radius, OA is another radius, and angle P formed outside the circle. And please remember that earlier we were talking about the arc's measurement and how it is related. How is it related to the angle formed outside? But this time here, angle P and the central angle, that is angle AOB, right? These two together 180 degrees. An important point to be noted that if you are taking a tangent and radius, always the angle between tangent and radius is 90 degrees. I repeat, angle between tangent and radius is always 90 degrees. Not only here, I see that OA is radius and PA is tangent. The angle between OA and PA, that is 90 degrees. You know that sum of four angles of a quadrilateral is 360 degrees. The sum of four angles of a quadrilateral is 360 degrees. And if you take angle A, which is here 90 degrees. This is 90 degrees. And this one is another 90 degrees. So 90 plus 90 is 180. So the rest of the two angles, that is angle P and angle O together, 180 degrees. This is called a circumscribed angle theorem. So the measure of a circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc, which means, let me take angle ADB plus angle AOB equals to 180 degrees. Again, I'm repeating. So the measure of everything I'm shading. So let me take this part. So measure of angle P, measure of angle P plus measure of angle O, these two together 180 degrees. It's very simple to remember that in case if you take anything to the other side, then it subtracts. You know, when you move to other side, it subtracts. Not only that, if you are moving this one to other side, then you'll get subtraction. Let me give quickly an example. Well, so here, once again I'm repeating, that is angle at the center of the circle, angle at the center of the circle, and angle formed outside the circle by these two tangents is equals to 180 degrees. Therefore, here you can see that this is angle ACB. You know how to name it, right? Therefore, angle ACB plus the angle formed outside the circle, it is angle D or ADB. Either you can take. This is equals to 180 degrees. What is ACB? 135 plus X equals to 180 degrees. How do you know? Means this is by circumscribed angle theorem. You know how to isolate the value of X. Just simply we follow the inverse operation to isolate X. So take away 135 on both the sides. So 135 take away 135, you will end up with 0 there. X equals to 180 minus 135. You may make use of calculator, you get 45. The value of X equals to 45. Pretty easy. So let me take one more example. This one is, see that this is different. I'll do one thing. Let me take you to the next page. And I want you to see the difference between these two. Here, notice that one is the angle formed outside the circle, and this is the central angle. This is central angle, right? So let me take angle KNL plus central angle is KML equals to 180. The reason is a circumscribed angle theorem. Now let me plug in these values. This is X and this one is 120, which is same as the previous example. And you know how to isolate X, and I don't want to spend much time. So we go by inverse operation, take away 120, then the value of X equals to 60 degrees. And here I cannot use that condition. Why so? Why can't I use this condition? So just I am zooming in. The reason is, again, please see the major difference between these two. I see that angle formed by the two tangents is 50 degrees, no issue. And notice that I don't know the central angle. Please notice that I don't know the central angle. So if you don't know the central angle, then how to compute? Do you see that? You don't know the central angle. Then how to compute the central angle?